A ver, ven, enseñar una foto por Aguanta, no lo voy a enseñar.
A drug is administered to a patient, and the concentration of the drug in the bloodstream is monitored at time t major or equal than 0 in hours since giving the drug. The concentration in milligrams per liters is given by this.
Okay, now that we have the problem, we're gonna start with the flowchart, and the first part of the flowchart is to graph the function 5t over t squared plus 1, and we have the first problem, that is, what is the highest concentration of drug that is reached in the patient's bloodstream? Well, that we have the graph, we graph the function, so we know the answer. This is the highest concentration reached by the drug, so we can know that this is the highest concentration of drug in the blood.
What happens to the drug concentration after a long period of time? Well, we can see that after a long period of time, the drug is approaching to 0.
The third question was, how long does it take for the concentration to drop below 0.3 milligrams per liter? This was a little bit harder. We need to insulate the main equation with the variable c on 0.3. So we do the equation, we substitute the 2 squared plus 1 is equal to 5t. Then we do the it's equal to 0. Then we use the quadratic formula. We substitute plus 1 and we have the result, that is the two results, x1, x2, and the two results are 9, and this is our result.
Well, for the conclusion of this project, we found out that all the answers were in the graph. We just have to learn how to identify the factors of them. So as a result, this project helped us to practice a method that every doctor used to know. Like it's the amount of the drug that every patient has in his blood. So we learned how to calculate the time the patient rests in between every operation. Thank you.